Hi, everyone. Welcome to the webinar, Build ETL Processes for Data Lakes with AWS Glue. My name is Raghu Prabhu. I am a Global Business Development Manager for Data Lakes at AWS. So let's get into it. Okay, so we're going to talk about ETL, and we will talk about ETL on AWS Glue. But before we get into it, what we want to do is get a baseline for certain definitions, just to give us a foundation for the upcoming discussion. So first of all, serverless. What's serverless? Most people may already know about this. It's an execution model. It's an execution model where you as a consumer, you want to run a particular workload. You want to, in this case, you would be doing some transformations. And the provider, in this case, AWS, will take care of all the servers. You don't have to manage any of the servers yourself. That's serverless. Next, ETL. We all know ETL. It's been around for 20 plus years, ever since data warehouses got popular. It's extract, transform, and load. It means that we are moving data from one place to another place. And as we move this data, we are applying certain transformations to the data. The third, ELT, it's also quite popular, and we see this more popular with users who are more comfortable with SQL. This is also data movement, but it is extract, load, transform, which means that you extract the data from your source, you load this somewhere, like in a database or a data warehouse. You have your scripts, which are SQL scripts. You run those scripts, and those scripts will transform your data, and then you load it somewhere else. So that's extract, load, transform. So this is our baseline definition. Now let's talk about ETL. Um, we can all relate to all our ETL experiences that we have had, and I'm hoping to get a feel for number one, it just needs to work. ETL just needs to work. We all expect our ETL pipelines, scripts, and processes to just work and completely behave and not give us any kind of trouble. That's number one. Next, it needs to be cheap and affordable. I have not come across any customer who wants to pay a lot of money for ETL. You just want it to be predictable. You want it to be cheap and affordable, because ETL is means to an end. It's not the ultimate goal. You're moving data from one place to another. It's transport. So you want to pay as less as possible for transport, because that's really not the value prop. It needs to be cheap and affordable. Next, it needs to be flexible and customizable. Every business, every company is different. You have your own business rules and policies and processes. So an ETL process should be extensible. It needs to be customizable, where you can edit some of the things that the ETL system is producing for you, because your business rules are going to be different. Next, it needs to scale in terms of data volume and also the concurrency. This is extremely important, because once you write a process, if you write a process today and you are ingesting and you're transforming, let's say 25 gigs of data every time the job runs, your business is going to grow, your user base is going to grow, and you'll be moving a lot more data tomorrow. It might grow 2x, 3x, even 10x. So the script may stay the same as a process, but the amount of data that is being ingested and transformed will change. It will grow. And the ETL platform that you choose needs to keep up with that growth. It's extremely important that the ETL platform keeps up with your business. Finally, things break. And when they do, you want to know where it broke and what broke. your ETL processes and pipelines need to be debuggable. So these are some of the core pillars of any ETL process or a system. But today, we are talking about an ETL process as it relates to AWS Glue. So let's learn a few facts about AWS Glue. First of all, it went GA, generally available, in August of 2017. So it's been a couple of years that this service has been generally available. Second, it's a critical service for our customers who are building data lakes on AWS. Third, when you look at AWS Glue, if you haven't already, and if you go into Glue and you're looking at all the different capabilities of Glue, you will see that Glue has a lot of capabilities because it solves a much bigger and broader problems such as data lakes. So you will see that it has a lot of components. I have a few components in front of you. One is a data catalog. Glue has a pretty robust and extensible data catalog. Then we have data crawlers. Data crawlers are a pretty significant component. They help you build the data catalog. Third, it has developer endpoints. Today, we are going to learn about developer endpoints and how you can develop your ETL scripts. Then we have job triggers. We will learn about job triggers as well. Then we also have bookmarks. Not getting into too much into bookmarks. It can be its own webinar, but just know that it is one of the components in Glue, very popular, especially with customers building data lakes. Then finally, Glue also provides the necessary infrastructure for serverless ETL, which is what we're going to get into and spend some time learning about the different aspects of Glue ETL. So here we are. Let's learn a few core points about Glue ETL. Number one, it's developer focused. Glue ETL is developer focused, but what does that mean? It means that you as a developer, you have written a script, an ETL script, where you are reading data from one or more sources, then you're applying a whole bunch of transformations to that data, such as maybe adding a column, splitting a column, joining this data with other data. So you are applying some transformations and you're writing this data out somewhere. So that's an ETL script. And Glue, like I said, is developer focused. What this means is you as a developer will bring the script and you will have Glue run that for you. So you as a developer don't have to worry about the infrastructure that goes behind running your script. Glue will manage all those things for you. So your job is to bring the script to Glue, and everything else from the execution, monitoring, for all those aspects are handled by Glue. Next, Glue has developer endpoints for developing job scripts. So if Glue is giving you the execution environment, that serverless execution environment, we also want to help our customers, our developers, to also build the script. So we have this capability of developer endpoints, which we're going to learn a little bit about in building those scripts, so you can run those scripts in Glue ETL. Then we have another capability, for more WYSIWYG, more drag and drop type users. We do have some screens, so you can click through the screens in Glue, so you can generate the ETL scripts. We also have that, and we will look and learn more about how you can walk through some of these screens to generate those scripts in the following slides. Finally, orchestration. It's fairly common where you will have more than one scripts. Our customers build pipelines. So think of this as you have a script, that's job one that does a particular thing. Then you have another script that is, say, job two that does a very different thing. and you would want to combine those together as orchestration, something like after job one, run job two. And for that, we have Glue triggers, and we will look into that as well. Okay, so we are getting into it. Like I said, Glue is developer focused, which means you come with the script and we will run that for you. But what's the execution environment look like for Glue? We have two popular execution environments. One is Python shell. With this environment, you are bringing a Python script and you are saying, hey, Glue, run this for me. And we will run that for you because we have the capabilities to do so with the Python shell environment. Then there is a second environment, which is basically an Apache Spark environment. In this case, you would come to Glue and you would give a like a PySpark script or maybe a Scala script and have Glue run that for you. The first execution environment is a non-distributed environment like Python shell. The second environment, which is the Apache Spark environment, is a distributed environment. So they work very differently in terms of architecture and also capability, and we're going to learn about them. So I like explaining things, taking an example. So let's create an example which we know is fairly common, and I'm sure a lot of you who are attending this webinar have done something like this, where you have an SFTP source. You got a whole bunch of files in the SFTP source, and what you want to do is you want to write a job and you want to download all those files from that SFTP source. Once you have downloaded those files, what you might want to do is apply a whole bunch of transformations on those files that you just downloaded, okay? Excuse me. Then there is a third job, let's say, where you may want to run, after applying the transformations that you want, you are running some scripts, some SQL scripts to further apply transformations to what you just already transformed. So it's a fairly common example. So let's walk through this example where you have an SFTP source and you have three jobs. Job one will download these files from the SFTP source. Job two will read all this data, apply a whole bunch of transformations to what you just downloaded. Let's assume that you are removing some columns because they are way too sensitive, things like that. And job two will also load this data into a data warehouse. In this case, let's assume it's Redshift. Redshift is our data warehouse system. So you're transforming the data and you are loading this data into a data warehouse, and that's job two. Once the data is loaded into the data warehouse system, you have another job, job three, that basically reads the data and transforms it even further, okay? So if you were doing this, and if you were to use Glue for this, how would you do this, okay? And we will add a little more attributes to this particular example. Let's say that we have to run this pipeline, every 6 hours. We are downloading and processing close to, say, 25 gigs of data, which is pretty significant, and we are applying some transformations. So we're going to walk through this example, okay? All right, so from the previous screen, we are going to, so these are some of the things that we have to do. How would we do them in Glue? What kind of components in Glue would we use to do these things? So for the first job, which is downloading from SFTP, I think the Python shell capability in Glue is going to be perfect. The reason for that is you can multi-thread this if you want. You can do this pretty easily using just Python. It's a very popular way of doing things, and you can just have this thing run for a couple of hours if that's how long it takes. And Glue will supply the execution for it. You supply the script. So we will learn about how Python shell works in the following slides, but to download files from an SFTP source kind of use case, I would use Python shell. Next, if you remember, we were going to process about 25 gigs of data, so fairly significant amount of data that we are going to read and apply some transformations on, which is job number 2. And we think for job number 2, it is better done in a Spark environment, in a much more distributed environment where you have a cluster. So you can process this in parallel using the Spark capabilities. So we will look at the Spark execution environment as well in Glue. Then the third job was to run a whole bunch of SQL scripts, because if you remember, what job 2 does is it loads data into a data warehouse system such as Redshift, and then job 3 that comes up after job 2 would run a whole bunch of SQL scripts. And SQL is procedural. You would want to run one after another. And again, for something like this, you wouldn't want to use a distributed environment. You would use something like Python, for which the Python execution environment in Glue will be perfect. Finally, this particular pipeline, we want to run this on a schedule, right? So it's something like every 6 hours. So for that, we will look into Glue triggers and learn more about it. So from here, we are going to learn more about Python shell. We are going to learn more about the Apache Spark environment in Glue, and we will also learn about Glue triggers. But before we jump into that, remember, one of the things that we started off with when we started this discussion is Glue is a developer-focused ETL offering, which means you come up with the script and we will run that for you, right? So the process of running something in Glue starts off with a job script. Once you have the job script and you want Glue to run that job script for you, you have to give what we call as a job specification. You need to tell Glue a little bit more about how to go about running the script. You may have to tell Glue that use a particular instance size because something is more memory intensive and you just want a bigger instance. If it's a Spark job, you may say, I want Glue to bring up a 10 node cluster or a 100 node cluster or a 3 node cluster. So tell a little bit more about your script so Glue can spin up the right environment for you. And part of your job specification is if you are using any third-party libraries or your own libraries, say your own Python libraries or jar files, you can import them. So part of your job specification is that these are the libraries I want you to import as you execute my job. And you can tell as part of your job specification for Glue to do that. So you package up your job specification, then your job script, and you deploy it. And once you do that, Glue will take the job script and the job specification, and it will run it for you. So this is the general feel for how things go when you're running jobs in Glue. Okay, so like I said, this is a developer-focused environment, which means you are coming up with the script. But we want to make it easy for our customers to come up with that script. We have a couple of ways you can generate that script, and these two ways are you can use both ways. Most customers do use both ways. One is a script generator. It's a WYSIWYG script generator, and we are going to see some screenshots of what that looks like, as a script generator. Second, we talked about this very little when we started this discussion, is Glue developer endpoint. Notebooks are very popular these days, and the couple of popular notebooks in the market are, Jupyter notebooks and also Zeppelin. So Glue Developer Endpoint supports both these notebooks. So if you're comfortable with any one of them, you can just start using these notebooks along with the Glue Developer Endpoint and start coding your job. But we will look at what the capabilities are of these developer endpoints as we progress. Okay, now back to this. Let's learn a little bit more about what these job specifications look like. And with job specifications, as you know, we have two environments in Glue ETL. One is the Python shell for Python scripts, and second is the Apache Spark environment. In this particular screen, we are going to learn more about Python shell, okay? And what are we looking at? We are looking at job specification in Python shell. So assume you have a script. You have a Python script that you want to run. And given our use case, let's assume it's a simple script that just downloads data from an SFTP source. So you would go to Glue, and I got a couple of arrows here to highlight some of the important aspects. You would pick what type of job that is. This is a Python shell job. The second option here is the Apache Spark job. But for this particular use case, you would pick Python shell. And you would put your script in an S3 bucket, and you would point Glue or Glue ETL or this job specification to where your script lives. Then on the second screenshot with the second arrow, this is a place where you can import your own libraries. So let's assume you have your Python egg files, if you will, and you want to bring them in. You can. The way you would do this is you would put those files in an S3 bucket, and you would point this job specification to where those files reside. So the Glue environment can download those EGG files and start running your job. From there, we have some of the other capabilities which you can learn more in your own time. Number of retries. If this job fails, you can say Glue just retry a couple more times, and you can control some of that behavior. You can also control the timeout behavior. Let's assume that the job just keeps running, and it has run for, say, something like 3 hours, and if that's an unusual behavior, you would much rather have the job stop and terminate. You can give a timeout, so you can control some of these aspects, runtime aspects of your jobs. So this is the job specification for Python shell. It's actually fairly easy. Part of Python shell, in that execution environment, we have preloaded with some of the popular Python libraries. As you can see, we have a pretty big list. We support pandas and NumPy, SciPy. Boto is obviously installed as part of the suite of libraries that we have. The nice thing about this is, if you want to use some of these popular Python libraries, you don't have to import them. You can just bring your script, and if it's a straight up pandas script, you're not importing any more Python libraries. It's already pre-installed, so you can just start using it, which is quite nice. So definitely look at Python shell. It's very popular, especially with the pandas group. We have had very good customer experience with this. So that's Python shell. We are going to talk about the second environment now, which is the Spark environment, which is a distributed environment. Now, if you go back to the example, in that example, this is job number 2. And job number 2 was going to process up to 25 gigs of data, something like that, fairly significant amount of data. And it was going to do some transformations like, drop some columns or split a column into 2 and then create a new column, just transformations, right? So For something like that, Spark is a great environment to do it. And we are looking at the Spark environment job specification screen. We just saw in the previous slides, we just saw the job specification screen for Python shell. Now we are looking at the job specification screen for Apache Spark in Glue ETL. And if you look at it, they look quite similar in terms of what these screens are, with some changes, and I'm going to point those changes out to you. First screenshot with the red arrow, you have the execution environment. In the previous screens you saw Python shell. Now you see Spark. So you pick Spark. Now the green arrow is actually very interesting. It asks you if you want Glue to generate the script for you. This is the capability that I was talking about a few minutes ago, where Glue has a WYSIWYG functionality where you can walk through a series of screens to generate a script. So it asks you if you want to use that functionality, and that's the green arrow area, or if you already have the script, you can just say that I already have the script, and then it'll ask you where is that script as in S3 location, and then you can move on to the next screen. So we will explore a little bit more on the WYSIWYG part in the following slides. Okay, so the third arrow, which is the blue arrow, we support 2 languages in Apache Spark. One is PySpark, which is Python, and the second is Scala. So you get the option to pick either as you develop your script or as you are bringing your own script. Then on to the second screenshot. We got about 3 arrows. The first one is you can import your libraries, your Python libraries. If you're dependent on some third-party libraries and they are Python, you can bring them in. On top of that, with Apache Spark ETL Glue environment, you can also bring in custom jars. So if you have your Java files, Java jars, you can compile them and bring them in as part of your Spark execution environment. Then take a look at the green arrow in the second screenshot, worker type. As you know, Spark is an all in-memory execution environment, which means it can get pretty memory intensive. Certain workloads can get pretty memory intensive. So to support those use cases, we have different types of nodes. We call them DPUs, data processing units. We have the standard node, and then we have 2 additional nodes. The standard node gives you 16 gigs of RAM, and the G1X and G2X give you magnitudes more RAM than just 16 gigs. So you have the flexibility to pick what type of node you want based on the jobs that you're trying to run. Then the rest of the screen should look fairly familiar with Python shell, which is the timeout, number of retries, so on and so forth. So before we move on, what have we looked at? We have looked at the job specification screen for the second execution environment in Glue ETL. Okay, so if those are the job execution environments, and as I've repeated myself many times, this is a developer-focused offering. It's a developer-focused product, which means you come up with the script and we will run that for you, either Python or Spark. But we want to help you with the job, with the script generation itself. And the way we do it, we got a couple of capabilities to help our customers in developing that script. Number one is the script generator, which we saw in the previous screen, where we have a WYSIWYG screen to help you generate that script. And number two is the developer endpoint, which is a more notebook-based experience. So let's look at the script generator. Before we go into the script generator, we need to talk about the data catalog, which is part of Glue. If you go way back at the beginning of this presentation, I talked about how Glue has a lot of different components. It has a lot of different capabilities. And one of those components is actually the Glue data catalog. So what is a Glue data catalog? It's important for us to understand the data catalog before we look at the script generation functionality inside Glue. A data catalog inside Glue is a metadata store, okay? Actually, it's a Hive compatible metadata store. And as you can see in front of you, I have a whole lot of tables in front of you. And if you look at the arrows, I have 3 arrows in the classification column. I have a table that is actually the data source is CSV. It's a whole bunch of CSV files. Then the second arrow, the data store, is in fact a table inside a Postgres database. Similarly, my third arrow points to a MySQL database. We also support DynamoDB. And some of these data sources in terms of Postgres, MySQL, Oracle, or SQL Server, Redshift, of course, these can be on AWS. Of course, Redshift will always be on AWS, but some of the other relational data sources that I mentioned, like the Oracle SQL Server, they can be on AWS, EC2, RDS, or even on-prem. This data catalog is meant to catalog all those different data sources. So you have a master data catalog of all these different tables, okay? So let's assume that you have cataloged some of your source tables. These source tables can be a bucket on S3 with a bunch of CSV files, or they can be, the source can be an on-prem table such as Oracle, right? They're all cataloged in this Glue data catalog, okay? Now, back to script generator. Now that you have cataloged this data somewhere, you want to transform this data from source to target, okay? And you want to use the script generator functionality inside Glue. I got a couple of screenshots in front of me. When you're using the script generator, it asks you what the source of this data is. So as you can see, you can pick any of these sources that can be S3, that can be Redshift, that can be a relational source, and then it'll ask you, where do you want to move this data, which is your target. It asks you if you want to move this data into a table that is already in the Glue data catalog, or you want to move this data into a location that is not actually in the catalog. You get both options, okay? So you pick your source, you pick your target, and then what happens? As you can imagine, it starts mapping the columns of your source and target. It has enough intelligence to sort of, bring like columns together because they are most likely to be mapped. So passengers from source will be, most likely mapped to passengers in destination. But you get some flexibility in this mapping screen to drag and drop the arrows that you see in the middle from source to target. You can say, I want to either unmap a column, or I want to drag this column mapping to a different column. You get to do all those mappings. You get to move things around. You get to also change the order of some of these columns. You get to drop some columns from mapping completely because maybe they're useless data or too sensitive of data. So in the screen, you get some flexibility to move some data around. Once you get past that, what happens? We generate a script. At the end of the day, we want to help you build that script so you can have Glue run that for you. So we generate a script, and as you can see, there is a script in front of you. In this case, it's Apache Spark. So I picked the Python as the language to generate the script. you can edit the script right where it is. You can edit all of it. And if you want additional transformations, right, where you say, let's say that you want to join this data with another data source, the arrow that we have, which points to the transform button, if you were to click on that button, you will see a list of transformations that we support. You can pick what kind of transformations you want, and what it will do is it will actually drop some code into this screen that you can edit. Minor edits you may have to do, such as passing some variable names, things like that, but it's a fairly easy process. And then they definitely take up on the transform button, because there are some very cool transformations that you can make use of. But ultimately, what this gives you is a script, which you can then apply a job specification and you can run that in Glue. All right, now back to this screen. If we are going to generate a script using the script generator, that's one way. Then there is a second way, which is the developer endpoint, which I talked about. A very popular way of generating, not generating, more like developing your scripts. What some of our customers do is they start off with the first method, which is the script generator method that I just showed you. They walk through those screens, they generate a script. Then they come into the Glue developer endpoint, right? And you get to choose either a Zeppelin notebook or a Jupyter notebook. Both are open sourced notebooks. A lot of people are already familiar with it. They copy paste the script that was generated by the script generator into these notebooks, and you get to play with it. You get to interact with this code. You get to fully understand what this job is going to do. So, which is a perfect way of actually developing the script. So you start somewhere, such as a script generator. You can add more transformations, but instead of just running the job, and having the job fail because something wasn't right, it is better to bring that script into something like a developer endpoint, use either of these notebooks, and interact with the code to make sure everything is working like the way you intended to. Interesting enough, the Jupyter notebook has ML capabilities when it comes to the Jupyter notebook with the Glue dev endpoint. This is a very cool functionality in our opinion. What we saw is that data scientists who love to use SageMaker, it's our ML offering, it's our ML platform. SageMaker comes with Jupyter Notebook. Most data scientists they want to use Spark as well, because you want to play with the data, you want to slice and dice with the data. And when you want to interact with Spark, you tend to have yet another notebook, a different system, which is separate from this Jupyter notebook that works with SageMaker. Now you have two different notebooks. It creates, it gives you a very disconnected system or a disconnected feel. So what we have done is, if you want to use the Jupyter notebook, we also give you a SageMaker instance with it. So if you're a data scientist and you want to play with code with say Terraform or any of the popular ML libraries, and you want to use SageMaker, but you also want to use Spark, you can use a Glue developer endpoint, so you can stay in one ecosystem and write your code. One final point as we move off of developer endpoint is you can control the size of your developer endpoint. You can get a 5-node cluster, or you can get a 10-node cluster. So you get to pick a couple of sizes and then keep your costs down. All right. So we're going to talk about Glue triggers. Before we talk about Glue triggers, let's just get a summary of everything that we just talked. Remember the example that we are trying to solve. Job 1, job 2, job 3. Job 1 is a Python shell job. Job 2 is a more distributed job. It's an Apache Spark job. Job 3, which is more procedural because we want to run a SQL script, is again a Python shell job. Part of our example also required us to build a pipeline. And it also required us to have this pipeline run on a schedule. And we wanted it to run for something like 6 hours, every 6 hours, something like that. So how can you use Glue to build orchestration so this particular pipeline runs on a particular schedule and have job 2 run on completion of job 1 and have job 3 run on completion of job 2, so on and so forth? How do you do that? To do that, we have Glue triggers, and I want to walk you through a couple of these screenshots that we have. Number 1, pay attention to the option buttons we have. We have the schedule or job events and on demand. Okay, we're gonna talk about the schedule option. So if you want to schedule a particular job, you have in the dropdown, you can see a bunch of these options, but the last one, which says custom, it allows you to basically give a cron expression of that schedule as well. So you can pick a schedule. The second part of job execution is to schedule our pipeline on a particular routine and have these jobs execute one after another. So for that, look at the arrow that we have job events. With job events, you can say, if you see this part, where my cursor is, I'm saying that I want to trigger subsequent processes on completion of these 2 jobs. I'm basically telling Glue, I want to look at these 2 jobs and have them complete before triggering these 2 other jobs. So this is a job event scheduling system where you can say on completion of one job, Glue environment is going to watch for that completion, and then it knows that there are subsequent jobs that are going to run on completion of these triggers. So with using Glue triggers, you can schedule a pipeline, and you can also build orchestration where you can have one job run after another. Finally, we are coming to the end of this discussion, but I want to take a minute and talk about Glue metrics. Now, going back, Glue has a couple of execution environments, Python shell and Spark, right? What we do as part of our job execution is we emit CloudWatch metrics. So we want to tell our users what some of these jobs are doing. My point here is, as you develop these jobs, look at the metrics. Please look at the documentation. Documentation is very good. Look at the metrics. Look at how your job is behaving. You could be way too over provisioned. Maybe you don't need 20 different nodes for the distributed Spark job. Maybe you just need half of that. And these metrics tell you what the job behavior is like, so you can size your jobs properly. So metrics are an extremely cool feature inside Glue. Definitely look at it. And I want to bring you back to the example that we started off with, and hopefully, you see how Glue can help you build some of these things. Given the discussion that we had, it's a significant system, and we try to cover it in the few minutes that I have. But I hope that you see the capabilities of Glue when it comes to different execution environments, different ways of triggering jobs and scheduling jobs. and the general capability of the Glue system itself, right? With that, I thank you for your time. I really hope this was helpful to you. Thank you.